Okay, these notes are going to be on inequality and interval notation. Again, I'm just going to assume that you already copied all this down. So we're going to be dealing with inequalities first. Inequalities are the ones that has that symbol. Just remember that if it's pointing to the left, then it's less than. I like to tell the students, like, if it can make an L, kind of like an L with your hand, then it's a less than. If you can't make an L, if it's going the other way, right, that looks kind of like a backwards L, then it's a greater than. Okay, so if it's pointing to the left like this, we say less than. If there's a line underneath, we say less than or equal to. That means we do want the point included. If it's pointing to the right, then that's a greater than. And if it's pointing to the right and has an equal sign underneath, then we say it's greater than or equal to. So how are we going to write our sets using inequality notation? Okay, so first let's focus on sets that are bounded on 2 points. That is to say, there's a start and there's an end to where your set is at, right? There's a start and there's an end to where your set is at. There's a start and there's an end. So on sets that look like that, first we're going to identify the boundary points. A boundary point is where it starts or where it ends, okay? Step 2, we're going to determine if the boundary points is part of my set. On a number line, if the boundary point is filled in, then it is part of your set and it needs an equal sign. So here it is filled in. If you notice that circle is filled in, that means the -3 is part of my set. So when I write my boundary point, there needs to be an equal sign underneath. If the boundary point is not filled in, or if it is empty, like in this case, it is not filled in, then the boundary point of 1 is not part of my set and it does not need an equal sign underneath. So that's what step 2 is about. Step 3, we're going to write our variable, in this case our x, so that it is included in your set. Remember that we always write our sets from smallest number on the left to our largest number on the right. So let's just go ahead and run through this really quick. The more we do it, the more you're going to be like, oh, okay, it's really not that bad. So first of all, I want to see, are there any boundary points? Where does your set start and where does your set end? I see that my first boundary point is at -3 and my other boundary point is at 1 because that's where it starts and where it ends. So I'm going to say my boundary points are -3 and +1. Which of those are included? Well, because the -3 is filled in, then the -3 is included. And because the 1 is filled in, then it is included. So we say that both of my boundary points are included. Since they are both included, how are we going to write this? Well, remember that we have the set of all x's. All my x's are everything that's shaded in, okay? So my x's start at -3 and they end at 1. And my x's are stuck in between. So that's the way I'm going to start writing my inequality. I'm going to go ahead and we always include it from left to right. So we're going to go less than, less than. -3 is less than x is less than 1. And now I got to check. Because they're both included, that means the -3 is part of my set. It needs an equal sign underneath. And the +1 is part of my set. And so it needs an equal sign underneath, and there is our inequality. This says my x's are stuck between -3 and +1, and we want to include those numbers in our set. Okay, so those numbers are shaded in. All right, let's take a look at the next one. What are my boundary points? On my next example, my boundary points are 1 and 4. That's where my x's start. That's where they end. So my boundary points are 1 and 4. Which ones are included? Well, the 1 is not included because it is not shaded in. And the 4 is also not included because it is not shaded in. So I'm going to say which of my boundary points are included. I'm going to say neither are included. So I don't want the 1 and I don't want the 4. All right, so just like before, we're going to start from smallest to biggest. My first boundary point is 1. My second boundary point is 4. My x's are all the numbers between 1 and 4. So I'm going to write my x are stuck in between. Remember, we write less than and less than. And because this 1 is not shaded in, then I do not want an equal sign. Same thing with this 4. That 4 is not shaded in, then I do not want an equal sign. That means this set is done. This says take all the x's stuck between 1 and 4, but do not include the 1 and don't include the 4. There's no equal sign under there. All right, last one. What are my boundary points? I see that my boundary point is at 0 and at 3. So my boundary points are 0 and 3. Which of the boundary points are included? Well, just the 0. The 0 is the only one I really want because the 0 is the one that's shaded in. So I'm going to say just the 0. What's my notation? Again, where does my set start? Where does it end? My set starts at 0 and it ends at 3. And these are all the x's that are stuck between those 2 points. Now again, we always write less than, and I check, is the 0 shaded in? Yes. Then I do want the 0 to be part of my set, so I put an equal sign underneath. Is the 3 shaded in? The answer is no. So I am not going to include the 3 in the set. I am not going to put an equal sign down here. And there is your inequality. All right, so that is using inequalities. Now let's go ahead and write these sets, but this time we're going to use interval notation. I want you to notice that these are the exact same problems here that we did here. The only difference is now, instead of using inequality notation, actually I should have highlighted that here. Instead of using inequality notation, this time I want to use interval notation. You're going to notice that it's very, very similar. Let's see. Step 1, identify the boundary points. Well, we know how to do that. It's just where my set starts and where it ends. Step 2, determine if the boundary points are part of your set. On a number line, if the boundary point is filled in, then it is part of your set, and you need to have a bracket. Oh my goodness, I just forgot. I just realized I did not highlight the last one. So let me go ahead and highlight this one. If it is filled in, then it is part of your set. And in this case, you need a bracket. When we did it the last time, we said the exact same thing. We said, if it is filled in, then it is part of your set, except over here, we needed an equal sign. All right, let's do the second part, might as well. If it is not filled in, then it is not part of your set, and you do not need an equal sign. Well, let's see what happens over here. On this one, if it is not filled in, then it is not part of your set, which means we're going to be using a parentheses. So on interval notation, there's a couple of things that change. You're not going to be using x's, even though we are talking about the x's. And instead of using a less than or equal to or just a less than, we're going to be using brackets when it's filled in and parentheses when it's not filled in. All right, and then step 3, you're going to write your interval notation with corresponding brackets and parentheses for each boundary point. Remember that we always write our sets from the smallest number on the left to the largest number on the right. All right, so let's go run through this. The more you see these, the easier they're going to get. Okay, so let's see. I want the set of all x's from -3 to 1. What are my boundary points? Well, just like last time, my boundary points for this example is -3 and 1. Which ones are included? Well, notice that both of them are shaded in, so I get to say that they're both included. And then lastly, we're going to use our notation. Okay, so here's where it changes a little bit. You're going to write your boundary points just like before. We're going to write -3. You're going to write 1. Here's the difference. Even though we are talking about the x's in between those two numbers, we are not going to write the x in between during the notation. We're just going to put a comma. All right, remember, these are both part of my set, so they both need brackets. So I'm going to draw a bracket on the left, and I'm going to draw a bracket on the right. This says take all the x's, start at -3, and shade all the way to +1. Because there's a bracket, we're going to shade in the first set. I guess I should put it here. And since it's there's a bracket, we're going to shade in the other set. Okay, so that's all that's really saying. Let's take a look at the next ones where they're not filled in. My boundary points are still 1 and 4, just like before. Which of those are part of your set? Well, this is empty, so it's not part of my set. This is empty, so it's not part of my set. So I'm going to say neither of these boundary points are part of my set. Now for the interval notation, we're just going to write, okay, where did it start? At 1. Where did it end? At 4. Is 1 part of my set? Technically, 1 is not part of my set because it's not shaded in. So I am not going to use a bracket. I'm going to use a parentheses. And is 4 part of my set? Technically, it's not part of my set because it's not shaded in. Therefore, I'm not going to use a bracket. I'm going to use a parentheses. Remember, what does this say? This says start your set at 1, go all the way to 4, We're going to circle it, but we're not going to shade it because it has these parentheses. This is saying like start the very next number after 1. So like 1.00001 or 1.0000001, but not 1, right? And then you can go get really, really close to 4. Like you can go 3.9, 3.99999, 3.999999999, but you can't get to 4 because we didn't shade in the 4. That's all that's saying, okay? All right, and then the last one here, same thing. We're going to do the boundary points. I got boundary points at 0 and 3. Which one of those points is part of my set? Just the 0, because just the 0 is the one that is shaded. If I want to write this in interval notation, you're going to write, okay, all the numbers between 0 and 3. 0 is part of my set, so I need a bracket. 3 is not part of my set, so I need a parentheses. This says take all the numbers stuck between 0 and 3. Do include the 0, but don't include the 3. That's what that says. All right, so those are the basic ones. When you have 2 boundary points, I think it's a lot easier for students to do. Let's talk about when it does not have 2 boundary points. It only has 1 boundary point. Okay, so let's see what this looks like. It says when the number sets don't have an endpoint, we use the infinity symbol for infinity. Infinity is going to be this sideways symbol. All right, so for these ones, we're going to do 2 different ways. We're going to do inequalities, and we're going to do interval notation when there's only 1 boundary point. Let's see, inequality and interval. All right, so for the inequality, let's see. I only see 1 boundary point, and I notice that it is not part of my set. But here are my x's. When there is only 1 boundary point, for your inequality, you're going to write x, and you're going to talk about the relationship of x and the boundary point, in this case, x and 1. Well, look at your x's. My x's are all these numbers over here. How does that compare to 1? That is to say, look at all these x's. Are all these x's less than 1 or greater than 1? Well, 2 is greater than 1, 3 is greater than 1, 4 is greater than 1. So what I need to say is that all my x's are greater than 1. Remember, the symbol for greater is this way. Now I got to ask myself, do I need an equal sign? Well, no, because 1 is not part of my set, so this is going to stay without an equal sign underneath. Let's do the next one. Same thing. Notice that there's only 1 boundary point. My boundary point is 2, and it just keeps on going forever. Okay, so there's only 1 boundary point. When there's only 1 boundary point for an inequality, you write x, and you write the boundary point. Now you got to talk about these x's compared to your boundary point. Well, here are my x's. Notice that your x's are like negative 1, 0, negative 1, negative 2. How do these x's compare to the number 2? Are these x's less than 2 or greater than 2? These x's are less than 2. So in order for me to use this symbol, I'm going to go ahead and write less than 2. Now I'm going to go ahead and look at my boundary point. Is that 2 part of this set? The answer is yes, because it's shaded in. Therefore, I know I need an equal sign down here. So I can say that these are all the x's that are less than or equal to 2. Okay, so that takes care of the inequality portion. Let's go ahead and start doing the interval notation portion. With the interval notation, we do still write 2 different things, okay? I say where my set starts and where it ends. Well, it looks like my set starts here at the boundary point of 1, except it doesn't really end, right? Like it keeps going forever. So we come up with this concept of this thing is going all the way over here towards infinity. So for interval notation, even though there's no boundary point on the right, we say, okay, it's starting at 1 and it's going towards infinity. So I'm going to write 1 comma infinity. Hey, let's put a thought bubble on this. I want you to write that infinities always have parentheses. Always. If you use an infinity symbol for interval notation, then you have to use a parentheses, okay? So let's see. Is the 1 part of your set? The answer is no, it's not part of your set. Therefore, we're going to go ahead and put it in parentheses. I always like to think of it like, is infinity part of your set? Well, infinity is more of an idea. It's not like an actual number. So infinity can't be contained. Therefore, it's not technically part of your set. Like, you're trying to get there. You're trying to get infinity, but you're never going to get there. It's not part of your set, okay? So we're going to go from 1 to infinity. And we're going to leave that parentheses. Always, always, always with an infinity. All right, let's take a look at the next one. Same thing. Let's see. I see that I have a boundary point here. I see that it's at 2. And then I know what some of you guys are going to say, like, oh, okay, that's also going to infinity. You need to be careful because remember, infinity goes this way. But my number is not going that way. My number is actually going this way. Well, if infinity is going this way, then what is going the other way? And I'm sure some of you guys guessed it, and you're probably right. This is going towards negative infinity. Now notice that negative fit infinity comes before the 2 does. So the negative infinity is what's starting your set. That means the negative infinity needs to go first. Let's see, the 2. Is the 2 part of your set? It sure is because it's shaded in. Therefore, that 2 on interval notation needs a bracket. Remember what we said about infinities? Infinities always have parentheses. So even if it's negative infinity, you're not going to be able to be part of your set. So you're going to have to put a parentheses on it. Okay, that's it for those 2 examples. Now you've dealt with when they have 2 boundary points. Now you've seen when they only have 1 boundary point. The 1 boundary point tends to be a little bit trickier for students. All right, so let's go ahead and practice this along. Let's see what we got here. Man, this is the second time I've done this. Let me go ahead and extend this number line because I realize that I need to get all the way up to 6, huh? So this is going to be 4, 5, 6. All right. This says start at -2 and go all the way to 6. Well, here's my boundary point at -2. Here's my other boundary point at 6. And because this says start at -2 and finish at 6, that means my x's are stuck in between. So I'm going to go ahead and shade all of these numbers from -2 all the way to +6. Does the -2 get shaded? No, because it's a parenthesis, so it's not part of my set. This is fine. Does the 6 get shaded? Yes, because it has a bracket. That means it is part of my set, so I should shade in that 6. So that's it for interval notation. That's it for the number line. Now I need the inequality. Well, remember that inequalities, when it's sandwiched like this, it's pretty easy. You just got to start off where it starts. It starts at -2. Where does it end? It ends at 6. And for inequalities, you do put the x stuck in between. These are all your x's. For inequalities, we go less than when they're sandwiched in between like this. And then does the -2 need an equal sign down here? No, because it's empty. Does the 6 need an equal sign down here? Yes, because it's shaded in. So I'm going to go ahead and put an equal sign down there like that. Okay, and then we are down to our last one. I want all the x's. Notice that there's only 1 boundary point here. So let me go ahead and circle that boundary point right now. And because there's only 1, they're telling me what my x's are doing. These are the x's that are less than 1. What are some x's that are less than 1? Well, that would be like 0, -1, -2. So that means this is going this way. All the way towards here. All right, so my number line is done. I see that I have my inequality. Remember that for interval notation, you need to tell me where it starts and where it ends. Okay, so where is this starting at? Well, it's starting over here. What should I write over here? Well, if you said infinity, you're close. If you said negative infinity, then you nailed it. Okay, so this is starting over here at negative infinity, and my set starts at negative infinity, and it stops over here at +1. So interval notation, it starts at negative infinity, it ends at +1. It's an infinity, so you never put a bracket on an infinity. I need a parentheses. And as far as the 1 is concerned, Notice that the 1 is not shaded, so this is going to need a parentheses as well. Alright guys, hopefully that made sense to you. As always, if you have any questions, please feel free to ask.